13.3 milliliters of 0.143 molar hydrochloric acid solution and mix it with 11 milliliters of 0.112 molar sodium hydroxide. What is the final pH when they are mixed together? This problem ties together doing a limiting reactant problem with pH. And so it's sort of the bringing together of everything or many things that we've done so far. Limiting reactant problems means that whenever you're given enough information to find moles of two different reactants, you have to do both of them. We will to find our limiting reactant, and then we'll find pH, and I'll tell you how to do that. So limiting reactant for this, start with your milliliters, convert them into liters by moving the decimal point 3 places to the left. So this is going to be 0.013. Liters times the molarity, which I will break down into 0.143 moles of HCl per liter. And from there, let's go ahead and figure out which one's my limiting reactant. For this particular problem, it doesn't tell you any product that you could try and figure out to find what your limiting reactant is. And I am going to do this a little differently than I did in the lecture outlines. Both ways are useful ways to do it. So, but I am going to actually find out one of my products. I'm just going to go to H2O. You could pick either one, but I know that for every 1 mole of HCl, there's 1 mole of H2O. And actually, that's all I need to do. So my picket fence is a little longer than I need. So 0.0133 times 0.143. I get 0.00190. Moles of H2O. Again, this is a limiting reactant, so let me do the same thing for sodium hydroxide. I have my liters, I have my molarity. And for every 1 mole of sodium hydroxide, there's 1 mole of H2O. And multiplying this out, 0.0110 times 0.112. I get 0.00123. Moles of H2O. So, because the smaller amount is the right here, that means that sodium hydroxide is my limiting reactant. And this is the amount of water that we can make. We don't really care about that. All we need for what we're doing right now is that sodium hydroxide is our limiting reactant. And that means that there is no sodium hydroxide left. And since HCl is our excess reactant, there will be some HCl left over. And in order to find the pH, you have to find out how many moles of HCl are left over. To do that, you can always start with your limiting reactant. So we're going to find our HCl left over. We know how many moles of, well, we can find out how many moles of HCl we started with. So the moles were going to be just right here. And if you multiply this out, you'll get numerically the same number you have here, 0.00190. Likewise, and here's where I'm going to take a little shortcut, the moles of sodium hydroxide, because there's a 1-to-1 ratio between HCl and sodium hydroxide, the moles of sodium hydroxide that you have will be the same number of moles of HCl reacted away. So 0.00123 moles of HCl reacted away. And again, that's the same number as my moles of sodium hydroxide. Do you believe me, or would you like to see me prove that? It sounds like people believe me. So now I know my moles of HCl at the start. So at start. I know my moles of HCl reacted away. I can subtract these two to get my moles of HCl left over. And I'm left with...
Professor, where did you get the zero on the final number, the 0.133 liter?
This number?
This number.
Yeah. I did see somebody say prove it. All right. Let me just finish this math and then I'll go back and prove it. So good question. 0.00190 minus 0.00123. 0.00067. Okay, so I did get a question that says, where did I get this number? And now let me prove it. So, okay, when you're doing a limiting reactant problem, the moles of your limiting reactant tell you everything that reacts, because all the moles of your sodium hydroxide reacted away. There's no sodium hydroxide left over. So if I start here with my moles, so let's calculate my moles of sodium hydroxide. So I'll start, right? It's like if you come back to your limiting reactant, you can always figure out everything else that reacted, that was either produced or reacted away. So this is my limiting reactant. I know this is how much reacted away. Then I know for 1 mole of sodium hydroxide, 1 mole. 1 mole of HCl also reacts away. So I get a 1-to-1 ratio here. And if I multiply this out, 0.011 times 0.112, I get 0.00123 to 3 sig figs. Moles of HCl reacted away. And it is no coincidence that that's also the moles of our products that are made. Any questions about that? Hopefully that proves it. If not, you'll have to let me know. I think that's all I can do to prove it. But I'm happy to talk more about it if anybody has any questions. All right, I don't see any. And then let's see how much space we have left here. So where am I? I know my moles of HCl left over. I now need to find my concentration of HCl. So it's going to equal moles of HCl left over divided by total volume. My moles of HCl left over are right here, 0.00067. And my total volume is going to be the sum of my two volumes here. So I'm going to add these numbers up to get my total volume. 0.0133 plus 0.0110, 0.0243. That's in liters. And to do this calculation, 0.00067 divided by 0.0243, 0.0276 to 3 sig figs. Molarity of HCl. And if it's anything we've shown over the lecture outlines in the last couple of homework questions, is if you know your molarity of HCl, that is the molarity of your H+, and you can use it to find your pH. So to find my pH, I'm going to take the negative log of this number. I enter it in first, I hit my log button, and then I take away the minus sign, leaving me with 1.56.